Hello, and welcome to my video. I hope that everyone had a good break, and sorry I can't be there today, but tomorrow we'll go over your midterm. But for today, I'm gonna go over with you loans, which was a part of the packet that you guys had before the break. It's dated February 12th, and if you have that packet, if you could pull it out, we're going to look at problems in here that deal with loans. So in particular, we're going to jump straight to example number 5. So if you look at this, it says that Carol just graduated from college and owes $24,400 on her student loans. The bank charges an annual interest rate of 3%, compounded monthly. If Carol wants to pay off her student loans using equal monthly payments over the next 8 years, use the formula below to determine what the monthly payment would be to nearest dollar. Now, if you recall before the break, we dealt with annuities, and if you look at the formula on the screen here, it looks perhaps somewhat similar to what you saw with annuities, except there are subtle differences in how this is all set up. But this is a formula that can be used when dealing with a particular loan, and the parts of this formula we see are listed beneath it, where this P sub n is the present amount borrowed, PMT is the monthly payment, N is the number of monthly pay periods, and I is the interest rate per month. So if we want to determine what the monthly payments would have to be, given the other information in the problem, we would just have to fill in the appropriate information into the formula and then use that formula to solve. So let's try to piece together what everything should be here. First, P sub n, again, is the amount borrowed, which in this case, in this problem, the amount borrowed is the $24,400. PMT is the monthly payment. That's our unknown, so if we want, we could just perhaps label that as our X. N is the number of monthly pay periods. So in this particular problem, payments are being made every month, and this is going to happen over 8 years. So the total number of monthly pay periods would be the 8 years times 12 months a year, giving us 96. And then the last thing we need to know to plug into our formula is what is the interest rate per month. And if you recall, as with annuities, you have to be careful. The interest rate provided in the problem is an annual interest rate of 3%. So we can take that, convert that 3% into a decimal as 0.03, but that's an annual interest rate. So we have to divide that by 12, and we get 0.0025, and that is our interest rate per month. And now we have all the information necessary to plug into our formula that we can use to solve for what the monthly payments would be. So using this formula, we can set things up and write that $24,400 is equal to our monthly payment, which is what we're trying to solve for. So we'll write X, and then parentheses 1 minus parentheses 1 plus our I of 0.0025, and that's all raised to the negative n, which is 96, and that's all over our I again of 0.0025. So now we have our formula set up, and if we just calculate what is in that bracket there, we would get, it should be 85 0.25460315. And then to solve for, again, what this monthly payment is, we just divide both sides by that 85.25460315, and we get that x is equal to 286 and $286. And we were told to round to the nearest dollar, so $286 is our answer to this problem. Now, the other problems in this packet, you'll notice, are dealing with perhaps different types of loans. Example 6 is a credit card, and they give you a formula that is pretty much the same formula that we just worked with, however just rewritten a little bit. So to solve these problems, you just have to identify the different pieces that you can plug into your formula and then just try to use the formula to solve. Now, I'm going to jump to example number 9 because there's an extra little thing in here that I just want you guys to be aware of that you need to know when dealing with a loan problem. So in particular, the thing that's going to be mentioned in this particular problem is what we sometimes refer to as a down payment. And a down payment is just sometimes when you go to take out a loan, instead of perhaps having to borrow the full amount that you need to pay for a car or a house or whatever it might be, sometimes you pay an initial amount up front to lessen the amount that you actually have to borrow. And that initial payment up front is what we call a down payment. So if we look at this example number 9, in part A it says using the formula below, so you see again that we have the formula, determine the monthly payment on a 5-year car loan with a monthly percentage rate of 0.625% for a car with an original cost of $21,000 and a $1,000 down payment to the nearest cent. So again, they give us the formula here and they tell us what each of the parts are, and if we're going to determine, in this case, what the monthly payment is going to be, which is the PMT, so I'll label that X, we just have to fill in for the other parts of our formula. So the first part, again, is our P sub N, which is the present amount borrowed. And again, you have to be careful here. Because of the down payment, the original cost of the car is $21,000. And if no down payment was made, then this would be our P sub N. But since a down payment, an initial payment of $1,000 was made, the amount borrowed is going to be the difference of the two, and it's going to be just $20,000. And then now our N again is our total number of monthly pay periods. This is a 5-year car loan and 12 months a year, so 5 times 12 gives us 60. And then lastly, we need to know the interest rate per month. And if you notice in this problem, unlike problem number 5, they gave us the interest rate as a monthly interest rate, right? So we don't have to make any adjustments. We just have to convert the 0.625% into a decimal, and that would be 0.00625. So now that we know all the pieces to our formula, we can plug them in to our given formula, and we would have P sub N, which again is 20,000, equaling the PMT, the monthly payment, which is what we're looking for, X, and then brackets 1 minus 1 plus our I, which is 0.00625. That's raised to the negative N, which again is 60. And then this is all over our I again of 0.00625. And then to solve for I, we would perhaps want to calculate what the value is inside this big brackets. And I believe if you calculate that, you should get 49.905.30818. And in these problems, you really want to try to leave rounding off until the very end of the problem. But to solve for our monthly payments X, we can just divide both sides by this 49.905 value, and we should get an answer of $400.76. So hopefully this video helps with understanding how to apply these particular formulas that involve loans. You guys should try to work on the other problems in this packet, the examples starting from example 6 to this example here, to practice these types of questions. And then we will go over these particular problems on Wednesday, the day after we go over your midterm. Right? Hope this again helps, and hope you have a great day. Take care.